This is the reaction of aqueous copper 2 sulfate and aqueous sodium hydroxide to create a solid copper 2 hydroxide and aqueous sodium sulfate. In the nanoscopic representation, the copper 2 sulfate solution is added to the beaker of sodium hydroxide. Water molecules are emitted for clarity. The particles then dissolve into the solution, breaking up into copper and sulfate ions. The sulfate ions do not dissociate, and the polyatomic ion stays intact. We have now added water molecules to show how the reactants are dissolved, as well as show the way the molecules would be oriented during this reaction. The amount of water molecules is not the exact amount as what we would have seen in the actual reaction, as this is simply an example. As we can see, the ions are now moving through the solution until they hit something they're able to react with. The first copper 2 hydroxide molecule is formed as each hydroxide gives up an extra electron to the copper, creating a neutral molecule. The ions continue to move around and react. Another copper hydroxide molecule is created, and the molecules begin to form a solid precipitate at the bottom of the beaker. The reaction has now reached equilibrium, and the molecules have settled into their final states of matter. Sodium sulfate is now an aqueous solution, and copper 2 hydroxide has formed a dark blue precipitate at the bottom of the beaker. So, what did we learn? We have learned how charges and electrons rearrange during a reaction, what kinds of compounds are soluble, and how water molecules interact with ions. We have also learned how it is important to keep our ratios constant throughout the representation so as to stay true to the law of conservation of mass. On the microscopic level, we've seen that the reaction occurs slowly, and we're able to see each electron and atom interact in different ways. On the macroscopic level, we see a change in the state of matter, as well as a change in color. We've also discovered that a reaction is always occurring, and even when it looks like it's finished, it simply reached equilibrium, and the rate of change between the types of molecules has become relatively constant.